Okay, the curve with this equation here has been likened to a bouncing wagon. Use a computer algebra system to graph this curve and discover why. So I put this into an online grapher. So there's the graph. And yeah, you can see this looks like a wagon, and it's riding on top of a hill, and it's airborne, like it's bouncing. Okay, now part B, at how many points does this curve have horizontal tangent lines? Find the x coordinates of these points. So, okay, this is not a function, because at one point x you have multiple y's. So yeah, this is y, this is x. But just looking at this, so it looks like there's a horizontal tangent there, maybe here, maybe here. So potentially 9 points where you have a horizontal tangent to the curve. So to find these points, we need to find the derivative with respect to the derivative of y with respect to x of that curve. So this is the equation for that curve. So let's use implicit differentiation to find dy dx. So our equation is two y cubed plus y squared minus y to the fifth Okay, so to do implicit differentiation, you want to take the derivative with respect to x of the entire function, of the entire equation. Not function, this is not a function. Okay, so this function distributes to each term, right? We're going to do the derivative of 2y cubed with respect to x plus the derivative of y squared with respect to x minus the derivative of y to the fifth with respect to x is equal to the derivative of x to the fourth with respect to x, and so on. Okay, so the derivative of 2y cubed with respect to x is, so first take the derivative of 2y cubed with respect to y, so 6y squared, right? And then take the derivative of y with respect to x. That's just dy dx, which is what we're looking for, right? The chain rule. So what we just did was d 2y cubed dy dx, right? So like you can imagine these cancel, and we get d of 2y cubed dx. But we started by doing d 2y cubed dy, which is just 6y squared. Okay, so let's do that again. So plus 2y dy dx minus 5y to the fourth dy dx is equal to, so now this is just like dx to the fourth dx. There is no chain rule here. This is just a normal derivative. So 4x cubed minus 6x squared plus 2x. All right, so we want to solve for this dy dx. So let's factor out the dy dx from the left side. So dy dx, you get 6y squared plus 2y minus 5y to the fourth. So now let's just divide both sides by this here. So we get dy dx is equal to 4x cubed all over Okay, so that's the derivative of y with respect to x. We want to find where this equals 0. So this equals 0 when the numerator is equal to 0. So when does 4x cubed minus 6x squared plus 2x equal 0? Let's just factor this. So first take out a common factor of 2x. So this is 2x squared minus 3x plus x. Okay, so factoring this, 2 times 1, so we got a 2. 2 times 1 is 2. So 2 times 1 you could do minus 2 minus 1 is minus 3, and then minus 2 times minus 1 is positive 2. So we get 2x, and then using grouping, so 2x squared minus 2x minus x. So this should be a 2 or a 1. Okay, so and then plus 1 is equal to 0. Right, this was a 1, and now we've turned this minus 3x into minus 2x minus x. So now we've got 2x, x minus 1, and let's take out a minus here. Okay, so now we can factor out an x minus 1. Okay, so this derivative, this dy dx is equal to 0 when x is equal to 0, when x is equal to 1/2, and when x is equal to 1. That's the x coordinates of where the curve has a horizontal tangent. So at 0 and at 1 and at 1/2. So yeah, it looks like that crosses over all the points that we marked, the potential points. We have the right x coordinates. But since this isn't a function, we can't tell, we don't know, does it ask us at how many points does this curve have horizontal tangent lines? So I don't know how to answer that question. Anyone that knows how, if there's a way we can find this answer, because I'm not sure, since it's not a function, I'm not sure how we can. What we could do is plug those coordinates into this formula. Like we could, right? We know the x coordinates. If you're not at x is equal to 0 or x is equal to 1/2 or x is equal to 1, then it's not a horizontal tangent. We know that. But what we could do is, to find out exactly how many points there are, we could say, all right, like start off by plugging in x is equal to 0 and then solve for y. Well, that wouldn't work, because y can, once x is equal to, if you plug in x is equal to 0, you get 0 in the numerator. So what y is irrelevant. Yeah, I don't know. If anyone has a comment on the first part of this question, if there's a way we can find this, please drop a comment. Otherwise, I'll have to look into this and perhaps post another video later. But the purpose of this video was really to illustrate implicit differentiation. So I will see you in the next video.